Okay, so we have 4 more examples. This time we've kind of stepped it up. These are a little more difficult than the first ones we just tried. So let's go ahead and do this one first. So let's not get overwhelmed with all the variables and all the steps that we're going to have to take. What we need to do is just take it one base at a time. That's the best way to approach these problems. So first what I'm going to do is the numbers. The number portion, what we need to do is you just treat the numbers like you would normally treat the numbers. So what I have is 5 divided by 25. So what I would do is just, both of those numbers are divisible by 5, so I'd have 1/5. So that takes care of the numbers. The next part, I'm going to go ahead to the x's, so I'd have 6 minus 3, so that's going to be a positive 3, so it's going to be in the top, it's going to be in the numerator. Alright, then we have right here 4 minus 5, so I have 4 minus 5. You know what, it's probably better to go ahead and write it out like this. X to the third. And then we have 4 minus 5, so that's going to be a -1. And the w to the third power doesn't have anything to divide by, so it's just going to be w to the third power. So in these examples, I want to do like we did before and just get rid of any negative exponents that we have. So right here, I don't want to have that negative exponent. So what I need to do is I can rewrite this. I'm just going to write it right here. There's not that much space, but I can write it as x to the third. It's going to be in the numerator, divided by, or multiplied by w to the third is also in the numerator. The 5 just stays there. It does not have a negative exponent. It's not going to go anywhere. But the y needs to come down. So this would be your final answer. Alright, so let's go ahead and do this next problem. So this one, we're looking at what is it exactly that we're doing. A lot of times in math we just need to identify what we're doing here. Right here, can I multiply any of these? I have a w, I have an x, I have a p, and a g. So none of these can combine, and just a 4 is just a regular number. It can't combine with any of these variables. So the only thing that this problem is asking me to do is to get rid of these negative exponents. So to do that, I just write -4. That stays in the numerator because it does not have a negative exponent attached to it. I'd have w raised to the 4th power. Okay, so the z is actually raised to a negative power. So that's going to have to go into the denominator so that we can get rid of the negative. So we got rid of the negative. The p stays in the top. It does not have a negative to get rid of. And finally just g squared. So this is a simplified version of that. These mean the same thing. This is just simpler, where it just actually just has no negative exponents. Okay, so let's go ahead and go to our next problem right here. So we have this, we treat the numbers just like we would normally. So we just say 16 divided by 4, so it's just going to be a 4. After that, we're going to subtract here. So this one is a little difficult because I have negative, both of these are negative exponents. So what do I need to do? I still just subtract the top exponent, or the numerator's exponent, from the bottom. Or the top exponent from the bottom, or actually the bottom from the top. So I'd say -6 minus a -3. So I'll write it right here so you don't get confused. -6 minus a -3. So when I have a negative times a negative, really it's just distributing in this negative. So really what I have is -6 plus 3. The -6 plus 3 is just going to be a -3. So this is going to be m raised to the -3rd power. I mean, this is just simple addition of negative numbers, so don't get overwhelmed with that. Okay, so right here I have an x, and right here I have a w, so I need to make sure that I'm seeing what I'm doing. I'm not just subtracting this from that because they're on top of each other. I have to make sure that the bases are alike. So right here I have an x and an x here. So I'd have 3 minus this 1. This 1 again is just understood to be there. If there's no number there, it's understood to be a 1. So 3 minus 1, it's just going to be x squared. So I do the w, I have w raised to the 5th and w to the 7th, so it'll be 5 minus 7. So 5 minus 7 is going to be equal to -2. So then I just have w raised to the -2 power. Alright, so right there, But we said we wanted to get rid of all the negatives, right? So here, I need to get rid of these two negative exponents that I have. So the 4 is not going anywhere. It's staying in the top. It doesn't have a negative exponent. The x squared, that's going to stay in the top also. It doesn't have a negative exponent. The only two we need to move are the m to the third and w squared. So that is the simplified version of this problem right there. So this one right here, what do we need to do? We have a power raised to a power. So we're going to just have to distribute this in to every single base, including the number. That's where you're going to make your mistake probably, is not distributing it into the number. So what I have is negative 2 raised to the 4th power, x, 4 times 5 is 20, x to the 20th, I have z, 3 times 4 is 12, g, 0 times 4 is just 0, and then negative 2 times 4 is negative 8. So are we done with this problem? Not yet, because we want to get rid of all the negatives. And also I have something raised to a 0. So what is anything raised to the 0 we said? It's just 1. So I can actually just eliminate this and turn it into a 1. And we don't usually write 1s because it has no bearing on the result of the problem. 1 times anything is just that, anything. So right here, what I have is negative 2 to the 4th. If I wanted to, I could say I have negative 2 times negative 2 times negative 2 times negative 2. So I'd say 2 times 2, negative 2 times negative 2 is positive 4, times negative 2 is negative 8, times negative 2 is positive 16. So we said all even powers of numbers are going to give us positive numbers, no matter if it's a negative or a positive to start with. We're always going to get a positive with even powers. So here we have just x to the 20th. Nothing's changed. It's just perfectly fine where it's at. Same for this one, z to the 12th power. That went away. And finally, I can just put k to the 8th in the denominator. And that is the simplified version.